We just finished up chapter 9, which deals with characteristics of integrated circuits, right? Any questions on that? These primarily deal with the data sheets. And we'll just pick out the first one, 74 LSO4. We did the center letters, right? So what do those tell us? In power. So this is what we call a low powered Schottky, a Schottky barrier diode, which allows us to switch a lot faster, right? Keeps it from saturating. Everybody understand the absolute maximum table. What is that? The absolute maximum rating table. Yeah, but inside these ranges, this right here might not be guaranteed, right? You understand? So what the absolute maximum rating does, it don't guarantee operation. It guarantees that it won't be damaged. There's a big difference, right? Y'all understand? So it's guaranteed that it will, if we operate it within that range, it won't be damaged, but it don't mean it's going to operate right. Then we have our recommended tables. And of course, TTL, standard power supply, 5 volts plus minus 5%. We've already talked about that, right? Minimum input is what? For high. Too low. Maximum input for low. 800 millivolts, right? And our outputs are guaranteed. This output is guaranteed at what? 2.7. So it's actually a little higher than what we use. So you'll find out that 2.4 for a legal high and 400 millivolts for a legal low is good for just about all these guys. Sometimes they're a little higher. Looked at the currents. Y'all understand the short circuit output current. So when we say this thing will output, so this is what it says it'll output for a high. Okay, it says 400 microamps, right? But down here it says it can put out to 100 milliamps. That's if what happens. If you short out the output, if you short it to ground, right, or common. And you can do it. And it won't hurt the gate for a while, but you don't want to do it real long. It really comes into play when we deal with trying to set up a tied AND or a tied OR, right? You understand? What's the propagation delay? Well, we're talking about the outputs. It's how long it takes the output to change with the input, right? You understand? So when that last input of an AND gate goes high, how long does it take the output to switch high, right? You understand what we're talking about? Of course, this is an inverter. We also talk about open collector outputs. What's an open collector output? Don't necessarily have to be a buffer. We got open collector NAND gates. We got open collector AND gates. We got open collector OR gates. We got open collector NAND gates. Every gate we got out there has the ability to be purchased as an open collector gate. So what's the feature of an open collector gate? Nobody knows. Am I the only one that was at the last class lecture? So, well, not another gate to it. The problem we like to do, of course, is we like to save as many gates as we possibly can. And we got two problems that we got is that I'm trying to run a load that requires more than 5 volts. So TTL is 5 volts plus or minus 5%, which means we can looking at on the power supply anything between 4.75 volts and 5.25 volts. And this is for standard or what we call commercial grade or consumer grade. Well, what if I got something that runs on a voltage above 5 volts? Well, we got one of two options. We could take the output of the gate, just say an inverter, and we could feed it into a bipolar transistor. And good gracious, guys, we could put maybe 30 volts up here, and we might be running a relay. Okay. But what we can only do, only thing this guy can really do is turn this thing off. For one thing, it can only source 400 microamps. Now it can sink 16 milliamps. So we'd have a problem with this guy, right? You understand? We're going to have a problem right off the bat because it won't be able to turn the transistor on trying to output a high. It'll be able to turn it off without any problem when it switches it to ground, but it won't be able to do what? Turn it on. Okay, does that make sense? Now we could come up here and do it like this. So I could come up there and put a pull-up resistor, right? You understand? And then we could come over and do this, and then put our relay right there. And this over here could be 30 volts, but this right here would still have to be plus 5. And plus, we're playing around with an active output, right? You understand that? So what we would like to do is we'd like to use this situation. In fact, we could do this situation right here, but I don't need that right there because now the resistor's turning the diode, turning it off. So what the inverter's doing is turning the transistor off. So when it outputs a 0, then the transistor turns off. So okay, I can turn it off, but now the resistor turns it on, right? You understand? So what I would use, so this is what we got right here. So the standard output of a TTL gate looks like this, and we call it a totem pole output, right? And we take our output right there, and then we got a resistor right there, and that's where the plus 5 volts at. So this guy right here, when it's on, we say it's what? It's sourcing, right? Y'all understand that? And when this guy right here turns on, it's what? Now, when this guy here sources, rule of thumb is, it all depends on what type you're doing, but this guy can only source around 400 microamps. We can't do much with that. Now, it can sink about what? 16 if it's standard TTL. If it's LS, it can sink 8, which is okay to turn it off. It's just hard to do what? Okay, well, what if I come up here, guys, and I do away with that transistor right there? Now this gate right here can't turn it on, but we're not turning it on with the gate anyway. We're turning it on with this resistor right here, right? You understand? So when this input over here, when this input right here goes to a 1, this goes to a 0, the transistor cuts off, and of course the relay would cut off. When I come over and put a 0 right there, this guy here can't output a high, but we don't need it to. Y'all understand? So the output of this guy here turns off now. It's not connecting the bottom of this resistor to ground, and now this guy can turn that transistor on. So that's one thing we use open collector gates for. We use them to drive transistors because we don't need the gate to turn it off and on. If we can turn it off with this 16 or 8 milliamps, which is plenty, right? You understand? We can let the resistor turn it on. Another thing we might run into is that I have to put this 5 volts over there. And you know, what if I can't get to it and I need to put the 30 volts right there? Well, if I was to put 30 volts across a standard transistor, it would do what? It would bop it. But we got a version that's called when we look at these two, when we look at the two gates, the 7806, it's a what? Open collector, high voltage output. So it means that output transistor can block, what does it say? I think this guy here can block 30 volts. So there's the open collector right there. So it just comes out. There's no sourcing transistor. All it's got is a what? All it's got is a sinking transistor. But we can use the output of this. So we don't want to use a standard output to drive a transistor. We'll usually use a what? An open collector output. And let our open collector output turn the transistor on, and then let a resistor do what? Turn it off. Now this guy right here can go all the way up to 30 volts on the collector on the output. So we could pull that up to 30 volts, right? If it didn't require over 16 milliamps, we don't even need the transistor anymore. So what I'm saying is, if it didn't need if it needed 16 milliamps, well, what I could do, because this guy here can drive, I didn't look, but it's usually around 16 milliamps. We'll look and see. You know, I could come up here and do this. Let's say I wanted to turn on a light or an LED. We'll see, we could do it what? I mean, we can do it directly without using anything. So we have open collector outputs, and another thing that we can do that we can't do with standard gates, that we're not supposed to do. I say we can't do, but I've seen people do it, and then they wonder why they have problems all the time. Is we can come over here. Now these are nothing but inverters, but you can get an open collector gate, a NAND gate. What can I do over here? I can come over here and do what? I can tie them together, and then I'll use the pull-up resistor. And this right here is called a wired AND. So what I've done is I've changed. I could come over here and I could have done that just like this. And it would have done the same thing. But what I did here is I saved the whole gate by using the wired AND, right? You understand? But anytime you see a gate that's connected to the outputs of gates, outputs connected to outputs, these guys right here have to have what? They have to be open collector. And of course, the telltale sign is that pull-up resistor right there. An open collector output will have a pull-up resistor out there. We'll have it. It's got to, because it cannot source. The only thing it can do is what? Sync. So what that means, we've got open collector inverters, we got open collector AND gates, we got open collector OR gates, and this is why you got so many dang 7400 series chips, is because you can buy them at 3 different outputs. We talked about totem pole and we talked about open collector, but later on we'll look at one called 3-state. So we can buy an AND gate that has a 3-state output. So that's why when you look at the series 7400 series, there are tons of them. Right? You understand that? Because these are all inverters. So if I go over there with 7404 is an inverter, 74SO4 is an inverter, a 74HCO is an inverter, a 74HCT is an inverter. So what we're doing here is changing the speed power characteristics. We're going to a different family of the same chip. I lost my home. Somehow I closed out my home page. I mean, but I think it's still open. Yeah. And I downloaded it while, but I didn't put it back up there. 7406. But I think we got the 7405. and the 7407 up here. I know we didn't have 6, but we had 7. No, we did have 6. So here's the 74LS06. That's the one we looked at, right? Where's Blackboard at? Here's the 74LS07. Now, what about the 7? Well, the 7 is what do we call this guy right here? We call it a buffer. So if I didn't want to invert and turn on a transistor, then we'd use a buffer, right? You understand that? So we got all these guys, you know, I mean, and these are just a few of them that's available to y'all out there. You know, if you go to a parts place like Jamico and just look at the 7400 series of '7400 series. Then we got surface mount chips. Same thing. We got a 7404 that's designed to be mounted, do surface mount. Now these are just the ones. These are just the ones that this company sells. I mean, and this is just page 1. We can put 50 per page. I think that's the maximum they let you put. But I'll show you all the actual parts catalog. They like to put a lot of pictures up here, and all the pictures are the same. See, a JK negative edge trigger flip flop. These are $4 a piece. They've actually come down. But, and here's a 64-bit RAM. So Schmidt trigger. Well, you know what a Schmidt trigger is now. So we got Schmidt trigger inputs. We got open collector outputs. We got totem pole outputs. We got all kind of other stuff that we hadn't got to. So are you okay on this section right here? Y'all gonna have any questions reading this thing? So what we're gonna make available to you on all the next test is you're gonna get data sheets on these things, and you'll be able to look this stuff up. We'll start asking specific questions about stuff on this thing. So if you don't understand it, you need to ask now. So anything on here you don't understand? By the way, on some of your data sheets, they call this the AC characteristics. It took us a long time to figure out what they meant by AC because it's syncing and sourcing, right? You understand? So the gate is actually changing the current. Now for next week's lectures, remember our class next week is going to be online. These are what? Recorded lectures. And then right here it says what? Yeah, what I've done is I've moved the quizzes in with at the bottom of the lecture to make it a lot easier for you to find. Okay. And then I just saw it cover this page. Yeah, it takes a little while for this page to load because and then this will be the 21st. It'll pop up on the what? 21st at what time? 8 a.m. So, and it'll disappear on the 21st at 11:59 p.m. So you got all day for this lecture. Okay, y'all understand that? And then what I've done to make it a little more manageable is I've split it into two parts, part 1 and part 2. And then at the very bottom you have the what? The quiz. What I've also done that I don't usually do because it's a little extra work on me is I gave you the link to YouTube. So all these videos are on YouTube. The problem with watching them right here is you don't have access to full screen mode. So if you want to watch them full screen, then what do you need to do? Just use that link, but you'll still have to come back here and take the quiz. Now, the two sections we're going to cover is we're going to cover Chapter 8. What's Chapter 8? I'm lecturing to myself up here. You're here. Chapter 8 is code converters, multiplexers, and demultiplexers. This is going to be the first lecture. And in the second lecture, we've already done chapter 9. That's what we just got through with. The next lecture is going to be on flip-flops. What chapter is that? So that's chapter 10. So chapter 9 is the one we just got over. That was the characteristics. So chapter 8 is code converters. That'll be the first lecture on Tuesday night, and then on Wednesday night it's going to be on flip-flops and registers, which is chapter 10. When you take the quiz, what can you use to take the quiz?
So we have to take the quiz on the same day?
Yes. Everything's got to be through. The quiz is actually your attendance. Okay. What can you use to take the quiz? You can use the textbook. You can use your notes. You can use the slides, whatever's available to you. Are you okay? For both the quizzes. If you got any questions, then you're going to have to email them to me, and I'll get them to you when I can. Huh? Don't call, no. You can text me through Remind, by the way. That goes through email. Yeah. No, 2 tries. Just like a regular chapter quiz. There's 2 tries per quiz. No, I've moved that quiz over here. So there is no. This is the chapter quiz for course content. So all it's been doing is moved here. I just thought it would be easier if I put them right at the bottom of the lectures than you trying to go over there to course content and doing the quizzes over there. Yeah. So only 1 quiz per lecture. But there's two parts per lecture, and I did that so it make it a little more manageable instead of trying to put a 3-hour lecture up there, and that way it'll be easy for you to break them up if you want to. And I did this on both classes, all the classes, guys. So I did the same on motor controls. And if you're in solid state, I did that on solid state too. And the quizzes are down at the bottom. So y'all don't have to go into the chapter quiz section to get to the chapter quizzes. They're down at the bottom of the lecture. Are we okay? Yes, and you do have to have the chapter quiz done on the same day. I mean, it's a whole day thing, guys. I mean, so don't wait till the last thing to do this, because 11:59 is going to go, right? Everybody understand that? Well, not if you're in it, but if you don't start the quiz before 11:59, it's going to be gone. So that's the big thing. It won't cut you off if you're inside the quiz. If you get started before 11:59, it will not cut you off, but it will not let you do what? Start it if it's past the deadline. Are you okay? Any questions? And then I'll go in and I'll look at the quiz, and that's what account is row. Okay? Any questions? Are you okay? Now this is for all the classes. I know some of y'all are in multiple ones of my class. A glutton for pain, right? Oh, you're in motor, yeah. And like I said, you can watch them here, or you can use the link. It'll open up in a different page, so you won't log out of Blackboard when you do that. It should open up on a different tab, and then you can come over here and do it full screen up here if you want to. But it's up to you. By the way, all these lectures are up on YouTube in my channel, but the problem is they're all up there. So that's why I put the link in the class to make it a lot easier for you to find them. Instead of trying, and Nancy don't have a YouTube channel, and so when Mr. Perry passed, she uploaded all those lectures up there for PLCs and the other classes too. So there's a bunch of them up there, about 200 and something. So okay. Another thing I did for y'all is I run this off for y'all so y'all know what labs y'all are going to be working on. See how far behind some of y'all. Some of y'all are okay, but right now y'all have the ability to go up through the exclusive OR and exclusive NOR labs. You'll see those. I don't remember which one. The HO labs, those are handout labs. They don't have a number. The other ones are in sequence, but they're the actual numbers that print off on the lab itself, and I print them off. That makes sense. Are you okay? You got any questions? Are we okay? Everybody know the plan for next week? Okay, guys, let's go lab.